I realized I had to hold my department for longer. And so I bought the pizza and like half the yeah, I got extra pizza. I think that's given a bunch of chili before that. Today, what foods like pizza or every other grain is the same taste.
Chicken nuggets.
Well, I'm not sure. I mean, I can try anything, but like,
Both. I don't see any or any variation.
I never use Xcode for debugging. Okay. I wish you'd like. Maybe you need to type their name or something.
Maybe, well, it's also because it's command line, so you have to type stuff in there.
Yeah.
So maybe there's weird. Good when they create lag. I think just having a
Okay, ladies and gentlemen, let's get to it. How are you doing? How many of you have started Project 4? Yeah? Okay, good. Okay, how many of you have not started Project 4? All right, okay, very brave of you. All right, let's see how that goes. All right, before we get going today, I've got an engine to show you. This one is a bit interesting. This is one of our first few proprietary and also non-public engines. If you want to use Crystal tools, the only way you can do that now is to go work at Square Enix and then go find the repository that's probably buried somewhere in their file share. This is an engine that was made for the Xbox 360 era, PlayStation 3 era. Okay, this is several eras ago in terms of console hardware, and console hardware was already an ecosystem full of cheap hardware, right? Remember, consoles, they're not really desktops. They're not Windows PCs. They're not Macs. Well, in a way, they are kind of similar to Macs. They are very, very cheap pieces of hardware. How expensive is the average? What can you get Nintendo Switch for today? Anyone know? $300. How about an Xbox One? 500. Okay. How expensive is like kind of a mid-tier graphics card? What do you got? $400. 500. Okay. And you need an entire console for the price of a mid-tier, okay graphics card. And that tells you about what you need to know, right? Consoles are where you need to really do some crazy stuff to get good performance. And so, the Final Fantasy series, how many of you have played Final Fantasy? right? This is a pretty famous series, perhaps the famous Japanese RPG series. And for pretty much its entire history, Final Fantasy has been about a generation ahead of its peers. These tend to be very, very, very good-looking games. This is a Reddit post. Just remarking on how good Final Fantasy 13 looks. And that game, when did that game come out? That game came out in 2009. Okay, so a long time ago, and it still looks fantastic. This goes back, though. Final Fantasy X on the PlayStation 2 also looked pretty great. And I believe it came out fairly early in the PlayStation 2's life cycle as well, and just looked fantastic. Looks even better if you put this in HD these days. You can go back even further. Final Fantasy VIII on the PlayStation 1, right? For a PS1 game, doesn't look too bad, right? You got some detail here. You've got some pretty good-looking characters and monster models, some nice backgrounds. It's good stuff, okay? So this was an engine, if I recall, it was created specifically for the Final Fantasy 13 series, which was kind of designed to be a trilogy, and perhaps even more beyond that. The problem, though, and this is one thing that can get you when you choose to go with a bespoke, custom in-house engine, is that the engine couldn't quite keep up. It couldn't arrive on time. It actually held the game designers back, at least on the first title. It had a very slow and kind of troubled development, and so the game designers had their own deadlines that they wanted to produce content, but if the engine can't support the village that you're supposed to create, that's a bit of a problem, okay? And so, well, what did the engine support? Well, here's what the engine supported. The engine supported environments that were basically like this, okay? They were very, very linear kind of hallways. In fact, I think these are literally some of the environments in the game. And what you do in this game is you basically run down a very beautiful hallway. You fight some battles, then you get to a boss, you watch a cutscene, and then you get warped after that to the next hallway. And you just walk down the hallway, fight some battles, fight a boss, cutscene, next hallway. Okay, and that was the entire game for about 30 hours. Okay? No real cities, no towns, no real exploration, not a whole lot of questing, no mini games. It was just this for 30 hours straight. Okay? And that was a big problem. Final Fantasy 13 is one of the most controversial in the series, and I would say it's reviled by some in a way that most of these games in the series are not. And so, yeah, it's basically the custom engine became a bottleneck. It was an absolutely gorgeous engine, but they couldn't get it to work with the features that they wanted, and so the game got dumbed down as a result. And it wasn't until the sequels where finally the game designers were able to kind of start adding things, traditional, JRPG elements like towns and exploration and stuff like that, okay? And so that is one of the risks that you take and one of the risks you should be aware of. If you just pull a standard off-the-shelf engine, then you kind of, you have an idea of what you're getting, right? You've seen games that have been made with Unreal Engine, with Unity, okay, what kind of games they tend to specialize in. If you make an in-house engine, you're kind of rolling the dice. It could be a flaming disaster, and because your engine, your technology is the foundation of your entire game, like that's it, right? If your engine is not good, that kind of caps how good your project can be overall. So, anyway, keep that in mind. It's not all roses in the world of game engines, okay? Quick announcement. Professor Nebling's My2 lab, the Information Interaction Lab, is hiring 2 research assistants, undergraduates, for the winter 2024 semester and perhaps beyond that, perhaps into the summer. If you are looking for some pay, if you're looking for something kind of like an internship, if you're looking for some research letters of recommendation from a research professor, you're taking this course. If you do a good job in it, you can get 1 letter from me. If you get involved with Professor Nebling's lab, that's another letter, and then that's basically into grad school. Okay, so if you're interested in grad school, consider opportunities like this. In particular, they're looking for people who have Unity experience, which a lot of you in this room do, and they're looking for people who have some VR and AR experience, which a lot of you do. If you've only got one of those, they'll still consider you. You should apply. And yeah, consider it. It seems like a really good opportunity. The team does some really cool stuff. You can learn more at their website here. And let me know if you have any questions, okay? I saw a really cool post from the one of the original developers of Age of Empires. This is 1997 game. Kind of a strategy simulation game, an RTS, real-time strategy game, kind of a sort of in the vein of like a StarCraft, and lots of stuff going on. And on 1997 hardware, right, the team had to be pretty clever. And this is a cool Reddit post, basically of one of the original developers piping in to kind of explain why the game has so much handwritten assembly code. Have you ever heard? It's kind of a romantic, dramatic story of like, oh, my code isn't fast enough. I'm going to go in there, I'm going to write some assembly code, LC2K, right? Oh, yeah. And I'm going to optimize things and get 10x the performance. As far as I understand, and I am not a low-level programmer, as far as I understand, a lot of those opportunities existed in the early days, in part because compilers were just not very good. They were not very good at producing optimized code. And there were a lot of interesting hardware limitations in that era, hardware quirks, where if you could write very manual assembly, then you could get a lot more performance than a C compiler, C++ compiler could get you, just because of your knowledge of the hardware. Anyway, so you've got some interesting stuff here. The vast majority of the code was written for the drawing core, which was basically allowed them to get kind of, they say about a factor of 10. Let me see here. Yeah, about 10 times sprite drawing speed improvement over the just C++ standard implementation. And that allowed them to actually have a higher resolution at launch than their competitors like StarCraft, which is really interesting stuff. Another thing that was interesting to me in here is that a lot of this developer's ideas basically came from talking with other programmers, even at other companies, over like lunch. Yeah, there's this stereotype, and it's going away, but still here a bit. There's this stereotype of programming being a very kind of isolated activity, right? We're in our basement, we're programming, we're making cool stuff, right? In reality, programming is a very, very social endeavor, okay? You really start to do hardcore programming, you get involved with an open source project. Pretty soon you're going to be talking with people, you're going to be asking questions, okay? Trying to get the scoop from the people who wrote the software that you're standing on, okay? You know, you learn a lot that way. I encourage you to talk about some of the high-level challenges you face in this course, right? You got homework problems you're thinking about. Well, think about them with some other people, okay? You might get some good ideas. Just do not copy and paste that code, okay? Another really cool thing is that, right, this is one of the original developers of Age of Empires, a game that's near and dear to a lot of people, right? They played it growing up. And this person is still alive. This person is still working, okay? This person just jumps in to the Reddit page when people start talking about his game, all right? Do not forget just how young this entire industry, this entire field is. And that can bring some friction sometimes, right? Game development is a kind of a wild place sometimes, okay? It's gotten a lot more stable in the last decade or two, but you can still feel its youth, all right? But that also makes it a particularly exciting place to be, okay? You can be in a new industry, a new art form. There's still new things to discover here, new things to explore, new things to say. And that's a great opportunity for all of you, I think. Okay? All right. Let's keep going. What do we got? Yes. Oh, in general, you probably won't find yourself writing like handcrafted assembly code much these days. Okay? Unless it is just something you're curious about doing or trying. In most cases, the compilers will probably beat you very badly, so don't worry too much. There is a quiz coming up. Quiz number 2 is coming up on Monday at our next lecture. and they'll talk about this. The staff will talk about this a little bit on Friday. But the topics we're going to cover are going to kind of cover some of those universal questions that you have to answer when setting up a build process in C++. Doesn't matter the IDE, doesn't matter the build environment you're in, there's certain things you're going to have to do, or certain questions you're going to have to answer for your build system. You should know what those are, okay? There's going to be some questions on pointer invalidation, on basic game loops, scenes and actor templates, which I'm going to talk about a bit more today. Standard containers and their complexity, okay? Complexity of different operations. We're also potentially going to give you some questions about shared pointer and STD optional. Has anyone used STD optional? Okay, all right. I'm going to talk about it a tiny bit today, at least help give you a feel for what it is and why you might choose to use it, okay? All right. Some notes that might help a little bit as you start to think about the performance on your homework 4. There's a concept called a composite key. Okay, so in homework 4, there's a very good chance that you'll want to be able to very quickly answer the question, what actors are at this XY position? Okay, now what are some data structures you could use to answer this question? Now you want really fast lookup, so you're probably thinking, okay, unordered map, okay, something like that. STD unordered map for the O of 1 lookup, O of 1 insertion, O of 1 deletion. The problem that you face here is that you kind of have two keys. You have an X that's probably an integer and a Y that's probably an integer, okay? Now there are some things you could do here, and you look at this first one. Okay, what's the problem with this first one right here I've highlighted? This is STD unordered map keyed with an integer, probably X, to an STD unordered map keyed to another integer that's probably a Y, and then finally to your STD vector that holds your pointers to your actors. Woo! It's nasty. Okay, what's the problem? Very verbose, yes, obviously very verbose, and you don't want to type that, but there's also another annoying thing you'll have to do. Anyone?
Like, every time we type it, also, like, the memory of that is going to be huge because of the way they use buckets.
Possibly. There could be a little bit more memory usage. You're going to have to write some annoying code, okay? Because the first time you go to insert like an X, right? An X of a certain value, if you don't have a map for that yet, a secondary, like second level of map, you have to create that and put that in, okay? Same thing with the vector at the end. So it's a little bit annoying. The code you write is going to be messier. Your performance, I imagine, is probably going to be okay. I'm not entirely sure. On this homework, you're going to want a benchmark. You're going to want to get your profiler out or use something like STD Chrono to time your functions and get a feel for what's working best for you. Another thing, and this might be the most convenient or easy for you, string, right, has a default hash function. And what you can do is you can create a little string here, right, X, and then some delimiter, and then Y, and then just use that as your key. Okay, your composite key. Now this is probably going to be pretty easy, pretty convenient. It might be a good place to start. It's probably not going to be as performant as you might like, okay, especially as the number of actors goes way up. Why is that? Yes?
Probably because you have to allocate a string for each key.
Yeah, it's like you're allocating and copying around a string, and that string is probably not going to hash as fast as the integers that you're using, okay, to hash. So not super performant, but I'll be honest with you, I think in general you want to focus, at least at first, on elegance, on code minimalism, on maintainability. When you run into performance issues, that's when you can go back and start to find, nice, hopefully not super messy ways to speed everything up. Okay, so I wouldn't say this is a bad idea at first, but maybe when you hit those performance test cases, you'll revisit it and you can make some upgrades there. This is one that's kind of interesting. STD pair. Now, question. I don't use this approach much. Does std pair come with a default built-in hash function? It doesn't. Okay, probably because it doesn't quite know. It can hash these two types, possibly, but it doesn't quite know how to combine them. So you probably have to write a hash function to combine these two into a single hash. But perhaps the most readable here, okay? It makes it very explicit that, hey, we're basically using two integers to hash into our map here. It makes the composite key really obvious what's going on. Yes?
If you're going to use pair, and you have to write your hash function anyways, it's better to just use IVEC2 directly, probably.
Yeah, one I didn't put up here is using IVEC2. Is anyone using that? Right? Yep. So you could try that as well. It's kind of a shame that they didn't provide one for us, but that's how it goes. Perhaps one of the most interesting things you could do is, and this is actually what the staff solution does, is it says, you know what? Like, we got a 32-bit integer, x. We got a 32-bit integer, y. Can we pack those both into a 64-bit integer and just use that as the key? And the answer is yes. And apparently, the performance is pretty fantastic compared to what we've been seeing to some other stuff. Here's a function that does this. You create a utility function, and you give it an x, you give it a y, you do some casting, you do need to do some bit shifting, right? You put x in, then you shift it over to make space for y, you put y in, and then you got your key. And you can use that if you want to. You can use any code you want to in this course. Yeah, well, hopefully it works okay for you. Yeah.
Did you say the maps could be like infinite size?
Yes, they could be, well, we're not going to use an x or y value that exceeds the size of like an int. So don't worry about that. But yeah, basically, you can't, in this project, you can't do what we did in homework 3, which is where we just created a big array, and you can't really do that. If you try and do that on some of the bigger test cases, you're just going to get blown up. Okay, so I do not recommend that. There are some things that you can try throughout your code base. There are performance differences in many cases between pushback and placeback and something like move. As far as you're trying to get an object into a vector or into a container, sometimes in placeback will give you a performance improvement. I'm not a super expert on the differences between these, but in placeback kind of says you're not really copying your object in, you're kind of building it inside the container, and that gives a small performance improvement. Move will allow you to move an object into a container without making a copy, potentially. That can get you in trouble because if you move it into the container and then you use that variable again, you get blown up, okay? Because it's no longer, the object is no longer where that variable was. So anyway, experiment with these, kind of know about them a little bit, play around with them, learn about them. Who knows, it could come up in an interview or it could give you a nice performance boost, okay? I need to do more timing myself to see how impactful those are, but there's been at least a little bit of impact, okay? All right, what else do we got? After class today, it's going to be about 11 p.m. when I get out of the XR film session we're going to do tonight. But I'm going to double the timeout time on the autograder. So you'll be able to kind of get a feel for if you're improving your performance on these final few test cases, with that change. Yeah, I don't think we've had anyone get a 100%, but I think we're very close. What's your percentage? Oh, you don't have to answer that, by the way, if you don't want to. But yeah, we're getting close. 96.6. All right, we're almost there. Good job. Yeah, the performance requirements on this homework are no joke, okay? They may take you a while to get to. All right, we had a fun Twitch comment on the last lecture that I just saw. I'm not sure exactly who this is, but they said, I will die before using the heap for my actors. And so it is time to press F and pay our respects because if you use pretty much any standard container like vector or unordered map or set or whatever, that object is going to put your stuff on the heap. And it will manage it from there, okay? It doesn't really you don't have to deal with that fact very much, but it's going to basically, like a vector will allocate contiguous memory on the heap, and then it will put it on there. And then if that contiguous memory gets too full, it will allocate a new block, and it will copy everything in, and then start adding new stuff at the end. So poor Kako, we will miss you, and we will never forget, okay? Thank you for your sacrifice. Okay, so today, actually I want to go through quick debugging tips first, and then today we're going to talk about how we represent digital worlds. And I'm actually going to show you, it's not a crazy complex topic, but it's kind of interesting. We're actually going to dive into some of the file formats that our popular modern game engines use, okay? Some quick debugging tips though. In the case that you ever find your program, your engine, kind of changing what it does every time you play, or in particular, if you get certain behavior on your own machine, but then it seems to behave differently on the autograder, there's a very good chance there's some undefined behavior going on in your program. This is the kind of stuff that can literally lead to your Boolean values just randomly deciding to start as true or start as false, and you don't know why, right? That could result in really weird behavior. This seems somewhat random. There's a very good chance that's undefined behavior, and usually our IDEs are pretty good at pointing out when there's something undefined that we're doing, okay? And so setting the warnings to W4, I think they start as W3. I think that's probably good enough, but and you'll start to get warnings about issues like this, right? You might see something like this, right? Variable actor velocity is uninitialized. You should really initialize this thing, please, okay? And keeping your warnings to a minimum is a good idea. Sometimes there are warnings that come from a library that you're using. Not a whole lot you can really do about that. Yeah, I would usually ignore those. Hopefully they're harmless. And if not, you'd hope the open source community fixed them pretty quickly. A lot of our dependencies, though, do not get updated that often. They seem pretty stable in general. Yeah, so I think that's just about it. Anyone have any questions about any of this stuff? Oh, I've got something. There's a little bit of a misconception, I think. Your resources folder gets introduced in Homework 4. That resources folder is a really cool folder, okay? As time goes on, you're going to discover that your game engine is in the binary, the game engine.exe, game engine win.exe, game engine _Linux, game engine _OSX. That's your game engine. The game itself is in that resources folder. In fact, you could take away that resources folder and grab a friend's resources folder, and you'd be playing a totally different game. Okay? That's how you could distribute different mods or different games. Okay? Same engine, same executable you're distributing, but it has a different resources folder right next to it. This is what your autograder will do for each test case on Homework 4 and for each test case going forward until the end of the course. Okay? Every test case is a new resources folder with new things in it, new configuration files, new images, new characters, right? New scripts, Lewis scripts, right? New scene files, new templates. And by filling out that resources folder, it's going to bring things to life, okay? So when you are editing and developing your engine this week on this Homework 4, know that we don't care what you do with the resources folder. It doesn't matter what you do from the autograder's perspective. That resources folder is getting deleted if you push it, okay? And the autograder is going to swap in whatever resource folder is needed for the test case at hand. You should edit the resources folder to do your own basic testing, okay? And that's basically what it is. In fact, you'll see that it is get ignored, which means we really don't want you pushing that in the first place to your repos, okay? Okay, any questions? Any comments? All right. Okay, so let's go ahead and let's talk a little bit about how we represent our digital worlds, okay? Because these things, right, I remember what it was like growing up, playing video games in the 90s, then in the 2000s. You look at an image like this, and you don't really think about the technical elements, do you? Okay? You look at a beautiful image like this. What do you see here? How many of you know what game this is from? Okay. So what do you see? What do you feel? Yeah.
So it's Elden, right? If I'm not mistaken.
Yep, that's right.
I don't know. You see UI elements. You see a character. You see
Okay.
a lot of stuff.
You see actors, right? You see characters. You see a grand adventure, right? A tree back here that's glowing with magical energy. You can get lost in worlds like this, okay? I think as engineers, it's very easy, because we're about to talk about it, right? We're making an engine. It's very easy to see only actors up here, vertices, faces, shaders, templates, right? But never ever forget that these simple basic things, right, when we combine them in the right way, they turn into things that are much more than the sum of their parts, right? You can see vertices here. You can see faces here, right? But in here are also memories, their relationships, right? Personal stories, growth, overcoming a challenge. Never forget that, all right? These really are magical places that can't truly be boiled down to just technical details, okay? Don't forget the magic, even as we delve deeper, okay? So, representing digital worlds, right? Beyond nice editor visuals, what do we really have here? Well, we can kind of write it down. We can start to anyway. Imagine that we have a simple scene or sample scene text file. You could start kind of cataloging what's in that scene that we see right there, okay? We have 3 actors, and you can actually see them right there in the hierarchy view, kind of the list form, the textual form of the scene view. And we got a main camera, we got a directional light, we got a cube, okay? You can actually see, yeah, the 3D graphical representation right here. 3 different icons, 3 different objects, okay? We have 3 actors, and when we examine those actors, when we look at them, we can see that, there are things that make them different, all right? We can see right away that each of them have a unique name, okay? Main camera actor, we got a directional light actor, we got a cube actor, but that's not all. You look at the inspector, you look at the details pane if you're looking at Unreal, and you'll see that there are actually a ton of properties in here, right? Has anyone gotten far into homework 4? Do you remember some of the properties that you need to care about in homework 4? What do we got?
X, Y, velocity.
Right, X, Y, velocity, X, velocity, Y. There's also blocking. There's also view, okay? So what do you want it to look like? There's a collection of properties, okay? And we can see things like that here as well, right? So we got position, rotation, scale for these actors. We've got a lot of other things as well, right? So we've got components, we've got collision-related properties. We've got mesh-related properties, some mesh data up there, a big collection of vertices and faces and all that. And so one question you should ask yourself is, how could we ever possibly specify all the properties that a user might want? Someday, we will need to make a switch. We'll need to start letting the users define their own properties. And if they're going to define their own properties, we need to help them define how those properties work, the logic that powers them, that uses them. Okay, we'll have to figure out how to do that one day. It's coming up soon, all right? But basically, right, this is not super complicated, right? It's actually very, very basic when you think about it. And if we want to actually create a format, right, for our scene files, well, we should probably go choose a format, right? Let's use a popular standard format. And a question for you is, why would we want to do that? What are some of the reasons we might choose an existing format? Yeah.
We don't have to write our own parser for it.
Okay. Yeah, we don't have to write our own parser for it, right? Yes.
Other people's tools work with it.
Other people's tools will work for it. Yep, that's right. So there might be some potential for interoperability, right? We also know that if a popular language format out there, markdown format, config format is out there, lots of people are using it, there's a good chance it will probably work for us too, okay? So that's a pretty good idea. And one question would be, well, which one? Which one should we choose? And if we were doing this in a really smart fashion, what we would probably honestly do is we would say, well, we should probably ask what Unity uses, Okay, the most popular indie engine, an engine that we're kind of emulating in this course in some ways. What format does Unity use? Does anyone know? Let's go ahead and look it up, okay? So you see here, I've got this Unity scene, and I've got a couple objects in here, a couple game objects they're called. These are basically our actors. If you look, we got 4 actors in this scene, okay? Our scene is called sample scene. We've got one cube right here, a game object called cube. It has a box collider, transform, all that mesh render. We've got a special cube over here, which is actually templated on this cube object over here. So it's called a prefab in Unity. We also have directional light, which has its own kind of light-based information right here. And we have a main camera, which has a bunch of camera information that is exclusive to it. Okay, these are all scripts in here on the side. We call them components in Unity. Okay, and so, well, let's find out what is in a scene. Okay, where is our scene file? There it is. It's got this cool icon within the Unity project pane, but we can open it up and see what it is on our actual file system. The sample scene file, it's a .scene file, and we can right-click, go to Edit in Notepad++, and see what we see. Okay, and here's the file. Does this format, right? It's maybe a little bit hard to read, but does this format, is it familiar to anyone? What is it? That's right. So this is a format called YAML. And as you look through here, there are a lot of things that might kind of catch your eyes and make it all a little bit hard to read. There are a lot of very big numbers in here. There are a lot of variables and properties that may not make sense to you unless you already know what occlusion culling is, okay? But basically, we have an object here called occlusion culling settings, and this object has a bunch of variables inside of it, including another object, okay, which has its own 3 properties right there. Some of the properties are integers. In fact, they all pretty much look like they are, but you can also have string variables. You can also have other stuff like that. You can actually have references to other objects. YAML is very powerful. We got render settings, okay, fog, is that on? No, it's not, right? Density of the fog, all that good stuff. Light map settings, okay? And then nav mesh settings, so AI related stuff. And then we hit our first game object, okay? We have a game object here, and one of the properties in here, and there are quite a few, is m_name, all right? This is the object, the data that represents our cube right here, right? So we should probably see that there are 4 components on it. And those components, we would expect to have some data associated with them. Indeed, look at this. We have 4 components, an array of 4 components, okay? And they are not really filled out right there on the spot, but they're actually references. So we can grab this number right here, and we can just kind of copy, control, and look for it, okay? And here is the ID and a comment, actually. And that is a transform object, which is exactly what we expect, right? And it has some properties in it. So local rotation, local position, local scale, okay? And so, interestingly, in Unity, they use YAML to kind of break up and separate the scripts and their properties from the actual actors that contain them, the game objects that contain those scripts, those properties, those components, okay? But you can follow things, it's not too hard, and you can find all the properties you need. This all looks very complicated. It's not actually too bad, okay? In fact, Unity used to have a binary format for all their files. They still do, but this textual format for their scenes is now the most popular. What's one reason they might choose to do that? Do they really expect us to be kind of looking through these files and editing things by hand? Maybe a little bit on rare occasion, okay? What's a really nice benefit of having an open, standardized, easy to read and parse format for the scenes? Yeah. Yep, Git version control. Diffing is a little bit easier, okay? But another big thing, tools, custom tools, right? On my own indie project, just a couple months ago, I wrote my own tool to basically read through these files and look for particular, I think, components, references that I really wanted to remove. And I think I had to do some other things as well. Basically, I just had to write a custom tool to fix something up, and I was able to do that because it was an open, kind of easy to understand format. Okay? And so, pretty good stuff. There are a couple other interesting things happening, though. There's this one object that is called Special Cube. And this Special Cube, let's see if we can find it here. Special Cube, can we find anything like that? The prefab instance, okay? We could find a prefab instance object, which is basically saying, hey, this is a template. And is the name anywhere in here? I'm not sure. Maybe the name is hidden a little bit. But basically, we have a reference in here to what the prefab is that we are deriving from. I think we have it in here. Oh, yeah, source prefab, right over here. This will take us into another file. Also, we have a bunch of overrides here, right? Basically saying, hey, we've taken this property from this other file. The property name is name, and we've changed it, okay? And if we didn't change, if this wasn't here, if we didn't change the property, then we would just inherit that from the prefab. Which prefab? It's going to be this one right here, okay? Cube.prefab. Let's open that one really quickly. Oh. Not sure why it's been doing this, but it really does not like me opening files on occasion. It just hangs like this. So let me see if I can get it going again. Restart Windows Explorer. I hope my hard disk isn't starting to go, because this is a new laptop. That's pretty spooky, okay? That's a Windows 11 thing? Look at how nasty that is. That's awful. Wow. Can I find it in here and open it in here? So that's the prefab. It's a .prefab file. Basically the equivalent of a, yeah, it's not going to open it. I'll give you the spoiler. It looks exactly like this game object right here, okay? This game object right here. It is more YAML, and if I recall, it looks like a pretty normal game object, okay? So we got some interesting kind of inheritance going on there, some asset reuse, and it's a pretty good time. So more formally, right, YAML, it stands, right, I mean, take a scene like this, right? YAML stands for yet another markup language, and it tends to look like this in Unity, okay? Not too bad. Once you know what the various things mean and how to find your components and find the properties within them. The official website, impressively, is written in YAML, okay? And you can go through it. The whole thing is valid YAML, and you can get everything you need, which is pretty neat. It was released in 2001, and compared to a lot of other formats, it has kind of a very minimal syntax. Now, this might not look that minimal, but as far as being a human-readable syntax, it definitely is, okay? Compare it to XML, all right? XML, where every single key name needs kind of an opening, kind of HTML style, right? Little key, and then needs a closing one with the exact same key name repeated, okay? It is very verbose, a little bit hideous, and yeah, not amazing as far as being minimal and being lightweight, okay? XML files can be very big. Unfortunately, it relies on white space to accomplish this, okay? There are no brackets or kind of enclosing scoping characters that you need. It uses white space, so it's very kind of Python in that regard. Has anyone ever been writing Python and accidentally, and you know what I'm about to say, accidentally mixed your spaces and tabs? Or you've had indentation levels that are slightly different and you don't notice right away and nothing works, right? And you can run into similar problems here, right? So that's a little bit tough. But YAML comes with some pretty cool exclusive features that you won't really find in a lot of other markup languages. One of them, as simple as this is, it is absolutely a killer app. is commenting. Okay, you can actually write some YAML markup and write comments that will then be ignored by whatever parser you're doing. And that really makes things easy if you start to do non-standard or weird or unique stuff in your actual markup, in your config. Okay? So that's super, super useful. It's a pretty killer feature. Anchors and aliases is a really cool feature. And this basically, one thing you'll notice is that within your config files, there's a lot of repetition. If you have a certain object in JSON that has a lot of the same stuff in it, you're basically going to have to copy and paste that stuff unless you've got an actor template set up for it. But actor templates are something that we build, that our engine supports. It's not native to JSON. Here, however, you actually do have stuff that is native to the language, right? So you've got this object in here, right? And you've got this little symbol, this and symbol. As soon as you use it, I believe this is called an anchor, and you can now actually just reference that, and it will basically copy and paste the contents of that object right in there where you put that little pointer sign, okay, the star. And this allows you to maintain dry, right? So you're not copying and pasting a ton of code. You don't have a bunch of duplicated stuff. And that can really, really help you and reduce the number of errors and your potential for making typos, okay? It also allows you to edit this in one place, and that change will then propagate every place you need it to. You don't have to fix up 1,000 different locations. Okay, so really, really cool features. And yes, these are references here to more YAML, your components with all the properties and stuff. This is basically templating, and in Unity it's just called prefabs. Another question is, what does Unreal Engine use? Anyone know what their format to representing their worlds, their scenes is? Let's go ahead. I want to show you an Unreal scene here. Okay? Oops, I kind of spoiled it. Here's our Unreal scene. All right? Actually, this is not our scene. This is the default scene. I'm going to double-click our map file to load it. It's a map file, a .umap file called level 1. And you can see it has a couple actors in here. Okay, one cube actor, a second one, a player start actor, and then some other things as well that are related mostly to aesthetics. So, for instance, the terrain in the distance, the sky, yeah, right, pretty cool. We can fly around and play the game just like that. Look at our scene. Very, very beautiful. Does an amazing job at that. And, okay, well, let's go ahead and grab this map file right here and see if we can find it. Show in Explorer. Hopefully, I'll actually be able to edit this one. I won't have to just tell you what it looks like. Okay, I'm going to right-click and, okay, show more options, please. Yeah, and it's just totally torched, unfortunately. I can't open up anything. But I do have an example of what this looks like. So this is a custom binary format, the UMAP format, okay? And it's going to look like something like this. You're going to see files that end with UMAP, okay? And when you open it, it's going to be a huge mess, all right? A bunch of soup, okay? And some of these, right, have some text string in here, and you can kind of read them, maybe make them out a little bit, maybe poke around a little bit and find something interesting. But it's a huge mess, okay? Not easy to edit at all. But surely there's a reason they went this way, right? Yes? Speed, efficiency, right? JSON is a, XML, YAML are beautiful markup languages that are very easy for humans to read. But you can compress the heck out of them if you're willing to get rid of readability. Okay, if you're willing to make things very nasty for humans to read, you can make them much smaller. Smaller files, you can read them faster, generally, and you can transmit them faster, upload, download faster. So for performance reasons, it can be a big deal. And if you know, what is Unreal Engine's kind of bread and butter? Why do you choose Unreal Engine as an engine versus Unity? What's that? Okay, C++ is its main programming language. Yep, and that's another big hint as to why you choose it.
Makes pretty games.
It makes beautiful, gorgeous, AAA bleeding edge titles. Okay? If you need the top performance, then Unreal is going to be there for you. And this is just part of that philosophy. Right? Performance is really, really important to them. Okay? The downsides should be pretty obvious. It's a little bit tricky to write a tool to mess around with these. You're mainly just going to be using Unreal, which will have the technology to unpack them and let you view them and manipulate them and resave them. Okay? It's also not super good for education, right? You open something like this up first time and you might just give up on game dev. You know, it's all too complex. I can't figure this out. Okay? Now, the open source champion of 2023, 2024 now, is Godot, right? Open source Unity, it is, okay? So let's go ahead and open up and look into Godot. Now, I have a feeling that we're still going to get trolled here, and Task Manager and Explorer is just not going to open for us, but I'll give it one more shot. Let's see here. Yep, restart task. Okay, let's go ahead and open up Godot. I've got a very basic project here. Right? When you look at it, how many of you use Godot in homework 1 and 2? Okay? Not many of you, right? I'm a bit surprised. We got 3 nodes here. So actors are called nodes. In fact, scripts are also usually called nodes. In fact, nodes are pretty much everything. They have kind of a recursive definition going on. So we got 3 nodes here, 3 actors. We have a ground cube. We have a player camera. We have a player light that is parented to that player camera. So when the player camera moves, the light moves with it. And then we have a final node, which kind of represents the overall container for this entire scene. It's called spatial, right? And we can play the game, and yeah, you know, this is what it looks like. Pretty simple stuff, right? When we go onto the into the file manager, if we can, yeah, and it just freezes. I feel like my computer might have a failing hard drive or something, which is not good. Not what you want to see. Oh goodness. Whew. Let's just be thankful Firefox still works. Yeah. Otherwise, this lecture is you're going to be watching a recording later tonight at like 2 a.m. So Godot, right? The open source champion. We have a couple objects here, a couple nodes. You can see the list of nodes on the left side. It's always on the left side. These are all packaged up into a scene file. So what we were looking at right there was actually level2.scene. Okay? It's TSCN. T stands for textual scene. Okay? Because Godot also has a binary version of their scenes, and they'll actually convert your textual version into a binary version, I believe, when you export it. And when you open it up, this is what you see. Okay? Level2.tscn. All right? What format is this? Anyone know what popular format this is? Yes. Is it Tamil?
Yeah.
I've never heard of that. Tamil. Let's see here. Tom's Obvious Minimal Language is a file format for configuration files. Oh, this does look okay, but I do not think it is actually Tamil. So this is a, and I'll explain why in just a sec. This is a custom textual format, okay, which is perhaps the most frustrating choice they could have chosen. All right. So if you choose a custom proprietary nasty binary format, you're probably doing that to gain performance that it provides. If you choose a standard, right, popular textual format, you're choosing it for usability, you're choosing it to speed up your dev time, to make your things interoperable, right, open up your tech to more of a community. But when you choose a custom textual format, it's unclear exactly what you're trying to accomplish here, unless your engine is just built in a way that a custom textual format is just perfect for it, but it's a little bit hard to imagine what that could be. Okay? Anyway, it's kind of a frustrating choice, and you'll discover that Godot has it's kind of an opinionated engine itself, and that it makes a lot of choices that don't make a lot of sense, personally. At least they did bring in C# eventually. You can program in C# in Godot. Originally, I think they only had GDScript, right? Their own proprietary, custom, cute little language. And if you learn it, you'll not be able to use it anywhere else ever. And you can't use any existing packages. And yeah, anyway, they do that kind of stuff a lot, it seems. But we have this textual script here. When you look at it, here are the 4 nodes that you expect. Okay? This is the .tsnc cn for level 2, which is, in fact, a spatial node. And so that's kind of the first node we've got listed here. We then have the other nodes, and they say that basically they're parented to the current file, which in this case is the spatial node. So we've got something of a parenting hierarchy here as well. That player light was parented to the camera, and you can see it right here. The parent is the player camera object, the node, and here is that node. Okay? If anything is edited or altered, you can find the properties that have been changed from their defaults right underneath that kind of bracketed node. Okay? And you just kind of read down and parse down until you hit the next node, and then you're done with the current one. Okay? You can see these nodes right there, and this is the hierarchy it kind of creates. And you can see parenting is kind of a unique feature that I haven't shown you quite yet in the other formats. The file format description is here on the Godot website. They seem pretty proud of it, and I guess it works fine for them. And this is why I do not think it is Tamil, even if it does kind of have a resemblance to it. Yep. So anyway, you can read about the file structure here, and you'll need to because it's a non-standard file format, and that's kind of frustrating. So one question you might have is, okay, well, so we've read about 3 different approaches here. Okay, we got YAML, right? Good for education, pretty readable, right? Very expressive. That's what Unity uses, right? Unity being the engine we're modeling things after, right? Might be a decent idea. We got a custom binary, super fast, proprietary format that Unreal Engine uses, right? We could go that way. And we've got a non-standard custom textual format with Godot. Probably shouldn't go that way. So what should we use for our engine? And the answer, of course, is going to be, those are options, yep. And the answer, of course, is going to be JSON. Okay? And so JSON, right? JavaScript object notation. Any web devs in here? Right? Very good chance, if you've taken 45 especially, that you're very familiar with JSON. And here it is, okay? If you have started on Homework 4, you're familiar with it already, okay? It is extremely popular as a format, and that's kind of part of how integral it is to web dev. And how early it kind of got in. It also got in around 2001. And it kind of became like one of the default ways that you send information between a piece of software on the internet. It was the origins of web development. It was right there. And you can see it has tight integration with JavaScript, as the name would imply. It is very human readable, and it's very easy to parse. There are a lot of very good parsers for JSON. I really like writing C#. That's what the autograder is built in. And the C# ecosystem has Newtonsoft.json, which is an extremely good JSON parser and serializer and deserializer. It's good stuff. Rapid JSON is what you're using in C++ on Homework 4. It is also quite awesome. C++ doesn't have any reflection facilities, or not really. But I think it is getting more and more. There's some proposals to add some additional ones. And basically, what libraries like Newtonsoft allow you to do in other languages like C#, ones that have reflection, is they allow you to kind of basically save your object instances at runtime, right? Save them to a disk. In this case, they'll become JSON blobs. And then at runtime, if you want to just load them up, you can just super easily load them up. It will just automatically work, and suddenly you'll have all your object instances back in perfect form with all their data, And you don't have to write any custom code to make that happen. It just works. Super nice and scalable and maintainable, just amazing. Anyway, it's interoperable, right? So this is a format that you don't have to agree on its form to make sense of it. It is human readable. Tons of different applications can use it. There are some cons. There are some downsides to this format. One is that it is kind of verbose. Now, it's not as verbose as XML, which is just crazy verbose, but it's not as kind of concise and minimalistic as YAML is, okay? It also kind of has a lack of features. That could be seen as a good thing, but like, would it really have killed them to add comments? That would have been really nice, and it's just not there, okay? Now, you might notice that all these problems are problems that YAML kind of solves. And so you might be asking yourself why we didn't choose YAML as the main configuration data format for your engine in this course. Any ideas? Now, there's a really good reason why we didn't do this. Yeah.
Is it not a good parser for it?
Oh, there are plenty of great parsers for YAML. Any ideas? The reason was I really wasn't familiar with YAML at all, and so I didn't choose it, and that's pretty much why. Now that I think of it, I can't think of a single game engine that uses JSON as its config format. It's just kind of a config format that you use for everything. My philosophy, and this is kind of an aside, I really, philosophically, I love to explore and understand an environment by hopping in without a huge plan. I like to get in there and form my plan by doing experiments and moving as quickly as I can. One of the downsides of that is that sometimes you can just like race past a really good solution because you found a decent one. And so in general, make plans before you embark on big projects. Don't make them super big, right? And make experimentation a part of your planning, but don't just launch in super quickly like I did, and then pretty soon half your homeworks are using JSON, and it's too late to switch, okay? Anyway, YAML, JSON, XML, these will all work, okay? And they're all pretty good. Lots of people use them. Lots of great tech is available for them. It's good stuff, okay? One kind of interesting thing, and I spoke to this earlier, is that in your homework 4, right, we have all these properties. Something to note is that for every property we add, you have to write a lot of C++ code to make those properties meaningful, right? We could tell our users that you can have like a favorite sandwich property, but until we write the code that adds that into gameplay and makes that value important, it doesn't matter. And that's really tough on us. That's tough on us, the game engine developers, because we don't know all the properties that our users are going to want. Okay, in a general purpose engine, we just can't know that. So in the future, we got to find some way to let our own users, our game designers using our engine, we got to find a way to let them add their own keys, their own values here, and they have to be able to make those keys do something. Plug them into some sort of system or calculation or change how the gameplay works, right? And so we're going to have to find a way to figure this out. Let them author data, but also let them author logic, okay? A quick aside, because XML feels kind of left out here. It's kind of it feels like the big 3 right now, YAML, JSON, and XML. XML is kind of pulling up the rear a little bit, I think. Extensible markup language. I believe this was Microsoft invented it. I'm not sure if that's right. A quick story, on the Sims 4 team, no human ever edited the XML. Our game used a massive amount of it, okay? In fact, basically any magic number you could find being used in our gameplay systems was represented in XML, okay? So how long does it take this type of sim to use the restroom or to cook a meal? All those numbers, those durations, were in the XML, okay? No human ever edited that XML, though. All the XML was auto-generated. What would happen is that the gameplay engineers, and that's what I was, would write a Python script, and that Python script would have some public variables or some variables that were given a special attribute. We would then have a C# tool that would crawl through the Python source code, And it would find those special marked variables and it would kind of bring them out, put them into XML. And that XML would basically be consumed by a tool that the game designers would use. The game designers used a tool called the tuner, I think. And they would be able to edit those properties, edit those numbers, edit those values. And they avoided all sorts of typos that way. Okay, the tool protected them. If it was a number variable, then they had to select or input a number. It would check it. If it was like a reference variable, they would have to click a list, and they'd get a reference to all the other things that you could link to. Okay. It also, it enabled code completion. So it allowed the game designers to know what their options were without having to look through the rest of the XML to see what they were. Okay. So, and then when you start the game, all that XML with the edited values that the game designers changed via the tool would get loaded back into the game engine. The public variables would basically get initialized. They would get those values put into them. And then, it would start running. Okay. And this is kind of how the Sims 4 team recreated some of those features we saw in Unity, right? Where you can, write public variables to create little tunable, tweakable parameters, and then edit those parameters really quickly without writing any code, and then make them actually affect the variable, the underlying variable, and thus the underlying gameplay. So pretty cool system, it worked pretty well. But there was a ton of XML, and I remember we had lots of loading issues on launch. I'm not sure if those ever got any better, but that's how it went. So a question is how to make asset manipulation and config easier, because you're going to be writing and messing with a lot of this kind of stuff, all right? Now, one day you would hope to be using a tool to do this. Then it would speed you up a bit, but it's going to be a little bit slow going, okay? Adding things and properties to your characters and testing and all that, okay? So when it comes to code reuse, you're very used to a few constructs, all right? Popular ways to reuse your code. What do we got? What's like the first thing you learn in like 183? Functions. Bingo. We got functions, okay? We also got things like classes. We've got inheritance. We got things like composition, if you take 494, right? And all of this is basically about helping us reuse code in multiple places and in slightly different ways, okay? And it's kind of telling that like code programming got all these nice facilities for reusing code. What did the asset designers get? What did the artists get? Did they get anything? Yeah, not as much, right? Not as much. Maybe because they couldn't code up the solutions to help them, okay? It's like, I feel like one of the first things a programmer does when they get frustrated about programming is they program a tool to help them program. And so that's why we're so flush with wonderful IDEs and all these tools. And anyway, all right. So there are cool things that can be helpful to us when we are not programming our game, but we're creating content for our game, which is what we're doing when we create a file like this, okay? Actor template, right? This is a scene right here. We've got 4 Spartans, all right here. And you look at them and you say, you know what? Actually, they're mostly the same, aren't they? Look closely. The only thing that differs between any of these Spartans is the position. You've got basically a common enemy type configured here, but we got so much duplicated data. Yes, we know that the Spartan needs to be blocking because it's a Spartan, right? We know it needs to have an S. We know that it needs to have the same dialogue because they all do, okay? And so what can we do to make things a bit drier, to make things a little bit more compressed, a little bit lighter weight, okay? If you don't quite understand dry yet, listen to this, okay? Imagine I have 1 million Spartans in my scene. You don't have to imagine it because it's test suite 6. Just wait, okay? What happens if one day I say, you know what, S just isn't what I'm thinking about right now? I actually want a capital S, more powerful enemy type. How many Spartans do I have to click and edit and click and edit and click and edit? Oh God, oh no. Okay, now if you're smart here, you'll probably like write a little script. Maybe get your AI to help you. Write a little grep script to replace all the tiny s's with big capital S's. But that's still going to take some time. That stinks. Okay, that happens because we're violating dry, right? We have multiple sources of truth. Every single Spartan has a duplicate copy of that view variable, okay? Here's what we're going to do instead. We're going to take the common stuff that all Spartans have. We're actually going to create an actor out of it, okay? It's a special actor, though. It's a template, okay? Basically, we load in and create this actor at runtime, and then when we want to create another actor based on it, we just kind of create a copy of it, and then we customize it with the new stuff, okay? So here are all the things that never change about a Spartan actor in our game, okay? And this allows us to refactor to the point where each actor just says, hey, I'm a Spartan. By the way, I do have unique X and Y values, all right? And boom, there you go. We've got better compression already. You can tell because now we've got about double the number of actors on the same screen real estate here, same zoom level. And we can also very easily change all of their view images with just one change, right? We just go into the template that they're all inheriting from, that they're borrowing from, change the small s to a big S, okay? Maybe we decide that we don't want the Spartans to be blocking anymore. Well, we just change that one false value and we're good. Just like that, okay? Very nice. Very nice. It's a critical feature. Like, we couldn't build an engine seriously without something like this, okay? Anyway, less data, right? So more compact. It's going to load faster, most likely. It's going to be far less likely that we write a typo here. It gets us that dry property that we want so much. Don't repeat yourself, right? No redundant information. And then changing the Spartan as a result is very easy if we want to later. So this is really important stuff. In Unity, this is called a prefab, okay? And actually, you can see it here in the Unity editor view. Any object with the blue name is a prefab. And if you want to know what the underlying prefab is, you just click select up here, and it takes it right to you. We can even grab that prefab and bring out more copies. You can think of prefabs and templates as like classes. And then every time we instantiate that class, right, we get another kind of instance of that template, okay? We can change them all by changing the template. Watch this. I want these all to be really tall. I could change them all manually, or I could go in here to the template that they all derive from. I could change the scale to 2 like that, and now look at that. They're all taller, okay? Just like that. Super fast, easy, nice. All right, cool. Okay, in Unreal, this is called a blueprint, okay? And basically, we got the same thing here. I got a cube blueprint, and I can just bring out more of these cubes however I want, and it's really nice. And then whenever I want to change how these cubes are, I can just go to the blueprint, I think. Can I click on this blueprint? I got to go in here first. I'm going to open the blueprint, okay? And I'm going to, open up the full blueprint. Okay, here's my object. And I'm going to go to its transform, and I'm going to make it taller, okay? Oh, that's not, I want the y-axis, or I want the z-axis, because okay, they're just big walls now, I guess. They make big, tall pillars. Okay, Control-Shift-Save, and then look at that. There we go. All right. So it's a universal concept to all engines, and it's good stuff. We got to choose a name here, so we're going with template, okay? Now, I'm not sure if template fits into our theater motif. Can you think of any like theater terminology that might be better? Anyone? Stage? Oh, that sounds like a level. Yeah. The problem is we're going to have a pistol in our game, right? And we're going to look at that, and when we say that's a stage, yeah, that suggestion is exactly what Godot did. Because guess what Godot calls their template system? Guess what Godot calls their prefab, their blueprint? A scene. And you get it, right? Because a scene is a collection of objects and properties that you can open up, right? You can make duplicates of, you can instance it. Prop, maybe? maybe a prop is usually referred to as like an object that's only meant for decoration and doesn't have a whole lot of interactivity or gameplay value. Yes, in the back.
Understudy.
Understudy. Okay, all right. Maybe like a role, because a role, and then you instantiate actors that play that role, right? And you can have a role, and then a bunch of actors can play it, right? But anyway, I think template gets the meaning across. Maybe one day you can change it in your own custom engines, and you can therefore have the best engine in the class, okay? Anyway, so templates are really good stuff, and one of your test suites in Homework 4 is all about implementing that. So how are you going to do it? Well, it's not that hard, but there are a couple things that you probably want to keep in mind when you do it. There is a little bit of nuance here, okay? So we've got our scene file, and we've got our template file, and if you look closely at both of these, right, you think to yourself, wait a second, right? Over here, I'm loading the template file. Over here, I'm loading the scene file. These things are basically the same, okay? Right? They are basically the same. And you should seriously consider, right, reusing your logic, right? You're probably going to write your logic first to just load a basic scene file, right? Each actor, right? How do you create an actor object using a document, rapid JSON document representing the object in the file? That code, I highly encourage you to try and reuse it for creating and loading your templates as well, okay? Create an actor object for every template at the beginning of your run. Encounter a template in a scene file, you just look that template up and you copy the actor object over, okay? You can then continue reading through these properties and set them as you like, okay? To override them if they're there. One thing that'll happen when you try and do this is something called a shallow copy. Has anyone heard of that? Has anyone heard of the concept of a shallow copy versus a deep copy? This is something that I can imagine showing up on your technical interviews. It's also something that can bite you, and it actually bit me midway through making, I think, Homework 6. Yeah, it bit my engine pretty bad, okay? The goal here, let's say, is to implement the actor templates feature, okay? And to be clear, it's to create an actor representing each template, and then we're going to copy the templates in order to create new actors that are based on them, okay? So let's say that I create a new actor actor object, okay? I've got an actor ID. It's -1 by default, let's say. Its position, a GLM vec2, or maybe it should be an IVEC, is 0, 0. It has a string, std string, called image idle. This is basically the file name of the image that our character has, okay? You won't have images yet, but you will have them next week, so look forward to that. Maybe you've got a second image for like attacking sprites, right? And then you've got a string pointer that points to the current image that your sprite is using, your character is using, okay? And it's currently set to null pointer. This is just an actor, right? You haven't done any copying at all. It's just a new actor object sitting there uninitialized, okay? All right. You have an actor template that you've loaded in previously, and you read that, oh, this new actor in the scene file has a template set, and okay, it's a Spartan. All right. And so you load that object up, and you say, you know what? I got my actor template here, and I'm going to copy it into here, okay? That actor template has actor ID 5, okay? It has a position of 0, 0. It has an image idle of 1.png. It has an image attack of 2.png. And its current image is currently at the image idle, which makes sense, right? Your character starts the game, they spawn in, and they're idling, okay? All right, so here's what we're going to do, right? We have the actor template. It already exists. It filled out. How do we perform the copy? It's super, super simple, okay? You have your new actor, which hasn't really been copied into yet. Right? It's just a vanilla actor, empty, really. And you can copy in the actor template's contents into that new actor like this, okay? And you end up with a shallow copy, a default copy, that looks like this, okay? And How you feeling about that? It's just you just copy the values over, right? It's got to be the same thing now, right? Right? Basically? Wait, what happened? What's the problem? Okay, there's one problem that's really obvious, then one that I actually didn't notice last night until I did. What's the problem?
I mean, you said that pointer values are the same thing, so both are pointed to actor template instead of, it looks like they should both be pointed like themselves.
Yeah, right? The approach we've taken here, in general, as soon as you've got pointers hanging out inside of your object, copying gets a little spooky in general, okay? This pointer, if you think about it under the hood, it's just an address, okay? It's just an address and basically an integer. And currently, it's pointing at the location of my image idle string. Okay, that makes sense for this object. But when we copy that object, by default, we're just copying all of these members just in the most basic way. We're just copying it over, which means we copy that address over, which means that our current image pointer is now copying to a value that's in a different file. Okay, a different object, which is like, that's not good. Okay, I don't think OOP, it's not really in the spirit of OOP, is it? And if it's a private, can you even do that? I wonder if, anyway, it's a bad situation, okay? Bad situation, but there's another problem, okay? What's the other problem? You can see it if you look carefully. Oh, is my pointer dead? All right, when you see it, you go like this, okay? Rip pointers, but also, yeah, rip your actor ID, okay? You've got a moldy, crusty actor ID that doesn't make any sense, okay? We currently have two objects using the same actor ID, which is going to cause some big problems, all right? Right, it's very easy. I mean, and that isn't even a pointer, right? It is, however, a number that is supposed to be unique to each actor object. And so you see, it's really easy when you're just doing copies like this to kind of get yourself in trouble. And maybe you can get away with it vanilla style on project, on homework 4, okay? When you get to homework 5, though, as things start getting spicier, homework 6, 7, like, it's gonna bite you, okay? So please keep this in mind. How can we fix this? It's actually not hard. Not super hard. How do we fix this? Yeah.
You do a deep copy.
Okay, you do a deep copy, right? Yep, you can do that. I'll explain what that is in just a sec. But at a more basic way, you've created an actor, you did the copy, and now we can fix it up, okay? Like this. You created a new actor, you perform a shallow copy of the template into that new actor. Okay, that's good. But now we need to fix up that current image pointer. You can set it to null pointer. Maybe that's a good choice. Or you could set it to your current image idle, right? That might make a lot of sense, depending on your gameplay. And then you need to refresh that actor ID. You know that's not valid yet until you have basically grabbed the next actor ID that is available. Now, if you don't know what we're doing here, basically, and then you're kind of in shape, okay? If you don't know how this works right here, this is a technique that's really nice and kind of elegant, and I recommend you use it. Basically, you can take a global variable, right, like next actor ID, static inline int, okay? By the way, does anyone know what does static mean? Because I feel like I explain this in every course multiple times, but then people keep asking what it means. Yes?
Like, it's only created once, and
Yep.
never have a copy.
That's right. So there are no copies. This is a single, right, class-associated piece of data. It's not an instance piece of data, not an instance member. It's a class member. So it is going to be here. It's going to be kind of global to this class. And so you can tell it basically, hey, give me the next actor ID, which is 0, and then increment that. Okay, and it'll be 1. So the next actor ID that we create will get 1 and advance it to 2. Okay, I've got a harder one for you. What does inline mean in this context? What is it kind of doing? You do need to have this, or you have to go put this variable definition into a CPP file.
And I think generally inline ones, they like tell the compiler to basically just like put the like stuff there like in the assembly, I guess, like so it's just always hanging out. But
Yeah, if it's a function, you're like unroll this function, kind of. So in this context, what inline is doing is it's basically saying to the compiler, hey, this variable is declared here, but also generate a definition for it, okay? I really am not a big fan of how you do need to put a variable in basically two places with just about the same syntax. And so if you put inline there, it will stop complaining and you will not have linker issues later. So just something to remember, might be useful for you. Anyway, it's good stuff, and that's a solution. The big takeaway here, though, is when you do any sort of copy, be very careful, okay? Shallow copy is super convenient, but we sometimes need to fix things up, and it can get us in trouble. Why is it convenient? Because a shallow copy, no matter what members you have in your object, the shallow copy will copy them over, okay? So you don't need to write new bespoke code to make that copy happen for every member of your actor object, of your struct, of your class. Because if you go with a deep copy, then you do need to do that. That's a big pain in the butt. Copy operations tend to be slow, especially as your data structure grows. So you, use pointers for things like indirection, might speed you up. What's a deep copy? Okay, this is basically when we take control of the copy operation via a custom copy constructor. I grabbed this off of geeksforgeeks.org. It's a good example, very good website. Though you do need to disable your ad blocker. It's been worth it for me, not a big deal. Do recommend. And you got an example of that here. We got a student class, right, with a few different variables here. Now we could just kind of let that chillax, but no, we have created a copy constructor which takes a reference to another student and then just kind of copies things over, okay? Not that crazy, but you can see here how it would allow us to inject some custom logic that says, no, don't copy over the ID, the actor ID, okay? Grab the next one instead. And so that would do the job, okay? The upside here is you can fix up IDs and pointers right here, and you don't have to worry about forgetting about it. The downside is that every single time you add a new field, okay, to your student class or your actor class, you have to go also add additional logic into your copy constructor because it will no longer just copy things over automatically, which is a big pain. I do not like that at all. And so I tend not to use them all that much personally. But it might be important depending on you. Whatever you want, okay? All right, some performance considerations. Copying of data can be pretty slow. It depends on how much data in some cases. A small actor, right, that has an actor ID, a position, a couple strings, current image, pointer. This could be 70, 80 bytes, okay, right? It's not nothing, but it's not huge. You can keep adding things, though, right? You might want to add things like health, rotation, right? And things start to get pretty big. I did a calculation, and my homework 7 actor was about 600 plus bytes. I'm not sure if that's still the case, because I think I made those things a lot more efficient on homework 7. But your actors are going to grow, okay? And as they grow, things might get a bit more painful, all right? Your goal is to make as few copies as possible. You can use pointers, which tend to be pretty small, to copy around smaller things, right? Avoid copying big assets. Later on in homework 5, you're going to be loading in big images and gigantic audio files into your program to play them. You really do not want to be copying those things around and making duplicate copies of that. Don't do that. Very bad. Very slow, okay? Be wary of your functions, and you already know most of this stuff, but just to kind of repeat it, emphasize it. This is pass by value into a function. That's going to make a copy of the actor. Bad news, okay? And it's really tough, right? Because it's only one little ampersand you're missing that really just tanks your performance. By the way, this is where a profiler in your IDE is really helpful, okay? If your performance isn't very good, hopefully your IDE can literally tell you, like, that function is a problem. Okay, and if that function is doing something really computationally expensive, maybe you say, okay, I get it, right? It's going to be slow. But often you'll find that really basic functions are taking a ton of your time, and you ask, why is it so slow? And you discover it's doing a bunch of weird copies, okay, you might not expect. Pass by reference, you learn this in like 183, okay, much more efficient in most cases, if you can get away with it, okay? And that's kind of very similar to basically you're passing a pointer, okay? You can kind of think of it in that fashion. Question for you, how many copies of my actor exist in the following code? Okay? How many copies? By the time this finishes running, how many copies we got?
2, like, within the scope.
Okay, which ones?
So there's the actor that you declared.
Yep.
And when you push back, it creates a copy of the name.
Bingo, absolutely. Yep, that's right. So when you run pushback, when you call pushback, it's going to create a copy of my actor and put that onto the heap, okay? You now have 2 actors here. And actually, if we had more code down here, you could keep messing with my actor and it shouldn't affect the one you put on the heap, okay? That copy could be expensive, especially if you're doing that constantly for 1 million actors, maybe, okay? That's a bit scary, all right? So another question, how many actors are there now? Yes, 1, okay? You've put your first actor onto the heap, and you've gotten a pointer so you can kind of keep track of it, right? You're putting that pointer onto the vector, and so you are making 2 pointers, but pointers are very small, and the performance could be better here. One really interesting thing that I didn't put in the slide deck, you can actually, I think here what you could do is you could use something called std : move. And what that would do, if I recall, I just learned about it a few months ago, well, it'll kind of move the actor away, like out of this variable and into the back of the vector. What's interesting about that is that you can no longer use this variable. If you try and use it, you're going to explode, okay? Segfault, blow up, okay? And it's very tempting to use it down here because it's a variable, right? I can use it. No, you can't. As soon as std move happens, you're dead. But you're not making that copy, which is pretty cool. Yes?
Yeah, you could also make a in-place back instead of pushback, so you don't even have to make the variable.
Yes, so there's some other functions that you can use as well. Yep. So what else we got in here? Blah, 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 blah. Yeah, difference probably won't matter much if you're using 10,000 actors, but if a user tries to run your engine on a potato, or if they try and use 1 million actors in the scene, then it's going to make a difference. Okay, and we want to support as much of that as possible. Okay. Yes, another thing that you can do if you're worried about memory safety. One of the tough things about pointers is that if you're using pointers, like in this fashion, if you're putting things on the heap manually yourself, is that you might forget to delete them. Okay. And especially if you're jumping from scene to scene, that can cause memory leaks. It causes performance degradation. And so you might consider, instead of using raw actors, you use something like shared pointer. Okay? Shared pointer is basically a pointer. However, it has the additional feature that as soon as all of those handles, as soon as all of those shared pointers got out of scope, that memory will automatically be freed for you. Okay? And so you don't really have to worry too much or as much about memory leaks and stuff like that. Yeah, Ravi?
You can still get wrecked with shared pointers.
Yeah.
The retain cycle.
Yes.
If you have 2 that point at each other, now the rest never goes to 0 immediately.
Yeah, that's right. So you can get wrecked by shared pointers. There's actually kind of a weird smart pointer called isn't it a weak pointer or something?
Yeah.
Yeah, what a name. But that is meant to help you break those cycles. But I feel like if you get into that situation, like things are just getting pretty nasty in general. Anyway, consider using shared pointers, and they are something that will help you manage your memory more effectively, prevent you from forgetting stuff, basically. Okay? By the way, as soon as you start to use shared pointers in a lot of different places, you notice that the language, C++, starts to feel more and more like an automatically memory managed language, like a C# or a Java. In C# or Java or Python, when you pass your objects in many cases to a function, in many cases you are passing by reference automatically. You're kind of passing a pointer around. And when those pointers all go out of scope, your garbage collector in those languages will kind of find those objects, will clean them up, get you space back. And so it really was strange. The more I started to use shared pointer, the more everything started to feel like C#, which I kind of liked. But shared pointers, as it turns out, are actually a bit less performant than raw pointers because they do need to do those checks. And they have to count how many shared pointers exist so they know when to free the memory. Anyway, it didn't feel super C++-y, so I kind of stopped. Last thing I got for you, and then we'll let you go here, std optional. Okay? If you have a property and you want to know if it isn't set yet, okay? Like this value is currently in an invalid state, it hasn't been set, it doesn't have a value yet. In many cases, that's pretty easy to do. A lot of data types have an obvious sentinel value, like string, okay? Hey, you want to know if your string hasn't been set yet? Maybe you could just allow that to be the empty string, okay? If you're doing an actor star, right, a pointer value, you always have something like null pointer as a nice sentinel value to say, we haven't set this value yet, it's currently nothing, right? It's null, okay, it's null. An integer might be, right, a good sentinel value for integer might be something like -1 to mean that, hey, you haven't set this integer value yet. We saw that a few slides ago. But what happens, right, what happens if you are trying to represent with this integer an x value, a position value, right, which could be -1. That could be a valid place, a valid value for that integer to be. What do? How do you find a sentinel null value, not yet set value, when your value could be just on the entire number line? You could try something exotic like -999, but some poor kid one day is going to want to set their character to -999. It's going to explode on them, okay? You don't want that either. So std optional of int gives you this value. Basically, it's a kind of a wrapper for a data type, and you can check it to see if it has ever received a value, has value, and you can get that underlying value via dot value, okay? So if you ever need to take a data type that doesn't have an obvious sentinel value, why is this here? Windows.
You right-clicked a bunch of times, they're here now.
Oh my God. So it took like half an hour for them to, oh no, what's going on? No joke, I sent this in and I didn't have a laptop for like 3 months while they fixed the screen. Okay, anyway, you can see some usage right here, right? std optional, enclose an int with that. You just set to 5. You can treat it like an int, but now that integer basically has a has value sentinel check, okay, to see if it's been set or not. Is it valid or not, null or not, okay? And everyone, that's all I have for you. I hope that this is, at least parts of this have been useful to you. I think the magic of this course really is in those assignments. And so I hope you start on homework 4 soon. And I hope you feel your confidence in C++ growing in homework 4. I also hope you feel your engine starting to come alive just a little bit. So that spark of creativity. You add a new feature. Well, what if I use that to create like a cool game, you know? I hope you feel that this week, okay? I definitely think you'll feel that next week with custom characters, 2D graphics, audio. I think you're going to like it, okay? Anyway, that's all. I'll be here for the next 2 hours. Then I got to go do a film session, so I'll be gone, okay? But I will upgrade the autograder tonight. Homework 4 is getting entirely new aesthetics. I thought they were too generic. Now they will not be. And the timeout on the autograder is going to double in time. So if you're hitting timeout issues, hopefully you won't be soon, okay? All right. See you later, everyone.
I was just wondering, where is that SceneDB file you showed in lecture on Monday?
Which one?
SceneDB.
Oh.
It referenced homework, and I wanted to just see what it looked like for reference.
SceneDB. Did I show people?
I remember, I think it was in lecture, but I couldn't find it in the slides.
Oh, I got to
You might
show.
have just showed it on your screen.
Okay, take care, everyone. Bye-bye.